Hi. So today we are going to performing this simulation in a LS-DYNA, and we are constraining this bar at one end and putting a N4 displacement at the other. So let's start. So to start, we have this block and we will try to hex map this first. We'll just go to this mappable solid and just hex map it, and this hex map is created. Now this faces, we will rename this as solid, and now solid mesh, and then we can just change this collector to this card name as part, because everything is part in LS-DYNA. Whatever your collector you are giving is treated as a part in LS-DYNA. Then we need to create some sets for for the boundary conditions. So this set will be of a node set. So we will just try to create two sets with the face nodes. So at one face we will fix it, and the other face we will just give enforced displacement. So the other set I'm going to create now. Done. This set I will rename as SPC move, and the other set I will rename as SPC fix. Now once this set are created, we will try to review this. Then we are going to analyze, and we will just constrain this the SPC fix in this star boundary SPC. So we will just switching on all DOFs, and we will just go to SPC fix. This is created. We'll just close this now. Now to create and force displacement, we just need to create one curve here first. So where is this curve? Yeah, there it is. So we'll just switch off the display in the curve first, and then we will just put 0 at time 0, it is 0, and at time 0.005 seconds it is 10 mm. And if you are not able to see this 0.005, that means you need to change your preferences here in the hyperview, that is numerical format, and keep it to 3. So if you switch on the curve, this is going to be like this, and we will switch off it, and now we are just going to enforce displacement, and we will switch on, we will select this, we will select the set, the SPC move set, and we are going to select the curve also. So this will be in X translation, that is set, and the curve we will be going to select whatever we have created just now. Once this should be X translation, that we will close this. Now once this is done, we are going to create some material properties and the property. So material, we will just keep on going to steel here, and we will just put a row as a 7.8 e power minus 9. By the way, this is in tons Newton units. So it is basically on the basis of that we are just using this consistent unit system. Then we are going to use property as is it a solid section. We will just put section as solid, and then we are just going to property and selecting the property we just created, and material whatever we have created the material. That's it. Now the this part is done. Now we are just going to create some ls this some dyna cards to how to the soft some cards of LS-DYNA. So first card will be a star keyword. Every job starts with star keyword, and then some title card, which is optional anyways, but we are going to keep it. That is done. Now we are just going to again this cards, and we just need to this control card we need to create, and this control termination we have just created, and we will put as end time as point triple double zero five. That is it. We want to run our simulation for that long, and then we will just go to this database file and D3 plot we want it, and we will just put the time increments which we want our results to be saved. Once this is done, these four cards are very important. Anyways, title card is optional. Then we can just export this deck to any folder. We are just exporting this now. Once this is exported, we can just solve this. We can able to firstly see this. This first step is control termination, and then all whatever we have done in the HyperMesh, it will be written in this text file. You can check it. So to run this, we will just open the command window, and we will just put the exe. We can just put this command and run this. So once this is solved, we will just open the results in the hyperview. So this normal termination means it is solved correct. It is solved without any problem, and then we will just going to review the results in hyperview. So this D3 plot we have opened. This is the results file in LS-DYNA. We are switching on the mesh, and we are just seeing the animation right now. So it is deflecting in the same way as we are expecting. And now we are just going to plot the displacement first. So I think this is some animation issue. Let's check this out. Yeah, this is some animation issue, don't worry. Yeah, it is behaving as we want it to behave. So we can plot this stress plot here.